So in class today we solved the circuit. Actually, I only showed you how the circuit would look like for t equals 0 minus, for t equals 20 minus, and for t tending to infinity. And then I told you that the VC of infinity is 2 volts and I of infinity is minus 1 milliamp. And in the previous video, we just figured out that VC of 0 minus is minus 6 volts and IL is minus 2 milliamps for t equals 0 minus. Some of you asked me how I found these two numbers for t tending to infinity, so I'm going to draw those again. But this circuit I'm going to draw a little bit simpler, so instead of making a curve there, I will draw the 3K and the 2K just in the same line. I think this is easier to see. I realize I don't have good lighting here. Somehow my lighting didn't work. And this is IL. And this is VC. I think part of the problem is how is it that VC is across the 2 kilo ohms? So the bottom of the circuit here, there's ground there, or it's the minus side of the capacitor. And the top of the 2K is the top side of the capacitor. So this VC is around the 2K because that is where it is here too. So if you follow the two nodes on the plus side and the minus side of the capacitor, you find that it is in parallel, or it's catching the 2K there. And the IL is the current through this one loop here. Okay, so this is the only circuit we need to worry about. And now let's see. In general, if you have a circuit like this and it's two resistors in series, you hopefully remember voltage division. And voltage division says the voltage across two or more resistors in series is directly proportional to their resistances. So if you see, oops, not 5K, this is 5 volts, is splitting between 2 and 3. What happens is that across the 3K, you have 3 volts. Across the 2K, you have 2 volts. And therefore, VC is 2 volts. Now, let's say you really don't like this way, or you're not convinced that it's 2 volts. And let's also say that you do believe the IL is going up. So let's do that circuit some other way. 3K, 2K. Let's do it the KVL way. This is 3K, this is 2K. And now IL is going up. This means the voltage across the 2K, the V2 is this way. And the V3 is this way because IL is going that way. And this is 5. Hopefully, so this is, if you understood this here, you are done. But to practice for the exam, maybe you want to solve it some other way. Assuming this current is going up, we're assuming passive convention, the voltage is going this way. And now I'm going to do KVL on this. So what happens is I write V2 plus V3 plus 5 equals 0. But now I want to write Ohm's law for V2. And V2's Ohm's law is going to be 2KIL. And for V3 is 3KIL plus 5 equals 0. So you see here the only way that this equation will work is that if IL is negative. So minus 5 divided by 5K is going to be minus 1 milliamp. So this is IL. So if IL is 1 milliamp and minus 1 milliamp, what happens is that V2 is minus 2 volts because it's minus 1 milliamp times 2K. No, sorry. No. So V2 is minus 2 volts, but V2 is the opposite of VC. So VC is pointing up. I'm going to change colors here. Oh, thank you for going behind the computer. Sorry, you're a very good boy. VC is pointing up while V2 is pointing down. So VC is minus V2. So VC is 2 volts. So hopefully this helps with the 2 volts and the minus 1 milliamp. I'm recognizing I didn't do the IL on that one. Okay.